Here we go. 5B, factorising expressions. In order to do this, you need to know the expansion rules, and then you're working backwards. So let's have a look if you still remember your 3 key rules from 5A. Distributive law. A plus B times D plus C is equal to what? Can I please have? Let's go with Sunny. What's this equal to again?
AD.
Yep.
Plus BD.
Yep.
Plus BC.
Still missing something.
Oh yeah, plus AC.
AC. Very good. I'm just going to put it here. A's together and the B's together. Cool. That's the expansion for distributive law. Perfect squares expansion, which is my expectation. I want you all to know and use this and not distributive law all the time. Distributive law is only for when the brackets are all different. Otherwise, I always want you to use these two, yeah? What is a perfect squares expansion? Violet. Beautiful. That is correct. And then difference of perfect squares. The first part of it, most students remember, and then the harder questions, if you watch the video, those are the ones I eventually want you to be able to do. Yeah. But what is the rule for difference of perfect squares? Let's go with Nishi.
X squared plus 2. Oh, wait, X squared minus B squared.
Beautiful. That's the difference of perfect squares. Okay, each one, every time you square something, that's technically a perfect square because you can draw a square with those particular side lengths. So a squared would be a length of a by a. Okay. All right, let's now do some factorizing. So it's a quick, easy exercise to write down the notes. So let's do the first one. Negative 2x minus 8. What is common about these two terms? So in this expression, I've got two terms. What's a common factor? Yes, Molly. We've got a 2, but there's also something else as well. Yes, Angelica? Negative as well. Now, at year 12 level, you don't always have to take it out. Sometimes taking it out does simplify the problem, and sometimes it doesn't. So you have to be a bit flexible with it. But usually, if you see a common negative, then take it out as well. So negative 2 is a common factor. So what goes inside the brackets here? Can I please have... Let's go with Jada. You've got negative 2 times x does give you negative 2x. That's correct. And then negative 2 times what will give you that negative 8? And you said 4. So it has to be plus 4. So negative 2. So that's one way to check it. If you factorized it correctly, when you expand it, it should give you the exact term above or the expression above. So, yes, that is correct. Negative 2 outside the brackets, and then it's x plus 4. Let's go to the next example. Same thing. I've got two terms. Again, 15a squared, and I've got a 20a. What is the common factor here? Can I please have... Yes, Yuna. 5a. Let's have a look. So 15 has 1, 3, 5, 15. A squared has a and an a. 20 has a 1, 2, 4, 5, 10, and an a. Yes, you're right. It looks like they both have a 5. Whoops. That's not 15. 15. Whoops. They both have a 5. And they both have 1a. So yes, 5a is a common factor. So 5a bracket bracket. What goes inside the brackets? Yes, Ahaj. 3a plus 4. And that is correct again. Double check it by doing 5a times 3a. You get 15a squared. Or 5 times 3 is 15. A times a is a squared. And 5a times 4. 28. That is correct. Well done. Next one. Now this one looks a bit tricky. What most students do at year 11, which is terrible, is they expand it. Then they factorize it. I don't want you to do that. I want you to tell me what is common about the two terms in this expression again. So this is my first term. So 3 bracket x plus 2. And I've got a bracket x plus 2. So what's common? What's common? Who wants to have a go? Nishi. X plus 2. Notice that this here is a number. We don't know what x plus 2 is, but it's being multiplied to 3, so it's a factor. This is also x plus 2, and we don't know what it is, but it is a number and it's times to a, so it's also a factor of your second term. That's why it is possible to say they both have an x plus 2. That's your factor. And then you ask the same question. X plus 2 times what to give you the first term? What goes inside the brackets? Violet. Very good. We got 3 because x plus 2 times 3 will give you that first term, and then minus a to get the second term. Okay, so it doesn't have to just be a letter. It can be another expression as well. Very good. So you got x plus 2 times 3 minus a for the third example. Fourth example, which I did last session. I got you to work backwards. Who wants to have a go with this one? Hands up. Someone else. Michelle.
Is it x minus 5 times x plus 5?
Beautiful. X minus 5 times x plus 5. Because your aim is to use difference of perfect squares, you need something squared minus something squared. How do you work out what goes inside? Just square root them. Square root of x squared gives you x. And square root of 25 gives you 5. So that's my a, that's my b. And according to the rule, it's a minus b times a plus b. So x goes here and 5 goes there. Okay, so that's one of the first steps. Let's try another one. So again, I'm now varying the difficulty, just like what I did yesterday. This is a bit of a refresher. How do you do the fifth one? What's the fifth one? What's the answer for the fifth one? Let's go with Andrea.
4a minus 5b, and then 4a plus 5b.
Beautiful. That was a tricky one. If you got that, well done. And again, those who don't know how to do it, it's difference of perfect squares again. Square of something, take away square of something. If you can figure out what goes inside those brackets, you then know what A is and you know what B is. How do you figure out what goes inside? Exactly what you did here. Square root them. Square root of 16 gives me 4. So square root of 16, and then square root of A squared gives me A. Square root of 5, I don't know. And then square root of B squared is B. So that's now my A squared minus my B squared. So Andrea then went with A minus B, A plus B. That's why it's 4A minus root 5B and 4A plus root 5B. Okay, you can do the same thing for the third example. That's a typical year 11 question there. Let's see. Let's go, Sanvi. Ooh. Okay, so we've got to the answer straight away as well. So you said x minus 4 and what was the other one? X plus 8. All right, let's check if this is correct. So first step again, difference of perfect squares. Your goal is to figure out what goes inside these brackets. Square root them. Same thing. Square root of 36. So I know that has to, that has to be a 6 there. So 6 squared gives you that 36. The minus is there. But then when you square root this one, what's the square root of x plus 2 squared? X plus 2. The squared and the square roots cancel out from the third chapter from last term. So therefore, that's my x plus 2, which really is actually the same line. That's already a squared term. So you didn't have to do anything to it. So it's x plus 2 squared minus 6 squared. So put it together, a minus b, a plus b. So you should have x plus 2 minus 6 and x plus 2 plus 6. 2 plus 6 is 8. So yes, Sanvi is correct there. And 2 minus 6 is negative 4. Yes, that is correct. So the simplified factorization there is x minus 4 times x plus 3. That there, those 3 examples are your typical 3 examples of difference of perfect squares. Okay? Last one being a typical year 11 question. Yeah? All right, let's go to the last one, or second last one. What happens when you can't square root it? But obviously we've seen with the 5th example. Who wants to have a go with this one? Hands up. I've chosen you two already. Someone, Raha? Beautiful. So this is x minus root 7, x plus root 7. Same theory. Difference of perfect squares. Square root them. You should then have x and a root 7. Last one for today. And that's pretty much exercise 5B, by the way. So, now this is a combination of a couple of skills that you've got there. First step is to find common factors. What are the common factors that you can see? You probably have to do it 2 separate ones there. Anyone figure this one out? Violet. Yep. Yep. Beautiful. That's it. So it's a 2-stepper here. This is similar. If you notice there, this is called factorizing by groups. If you're interested in the name, this is called factorizing by groups or grouping. And essentially you do it multiple times. So you do the first one, you say, well, they don't all have a common factor. So you then split them up in pairs. You find that this pair has an X, this pair has an A that's in common. What's interesting is that once you factorize them, they both have now a common factor of X minus 2. So then you take out the X minus 2 as a common factor, and then we can say X minus 2 times X gives you that. X minus 2 times A gives you that second term. That skill there is useful if you're going to learn how to factorize quadratics using the textbook method. So the textbook teaches through factorizing by groups. For some students, they struggle here. That's why they struggle in the next few exercises. I'm going to teach you a different technique. So even if you don't get this bit, it's okay. I'll still teach you a different technique to factorize for 5D and 5E. Okay? But that's the reason why they teach you that. All right? But that's it for today. So there are 3 rules there that will be helpful for you to do. You're working backwards. It's called factorizing. Reminder, so Monday next week, I want to see 7A, 7B, 5A, 5B. For those who were here last term, you only have 5A and B. For those who weren't, you got 7AB and then 5AB. All right, I'm going to stop the video.